Hi. So today's topic is number system of grade 9th chapter 1. So let us first revise what all numbers we know till now. So we know natural numbers ranging starting from 1 onwards, 1, 2, 3, and so on. Whole numbers starting from 0 onwards, 0, 1, 2, and so on. And integers consist of natural whole numbers along with negative numbers. So all these are integers. Now all these numbers can be plotted on a number line. Now let us see what are rational numbers. Rational numbers are in the form of P by Q, where P and Q are integers and Q is not equal to 0. So for example, minus 3 by 2, it's a rational number because minus 3 and 2 both are integers and Q is not equal to 0. And we can also take 3 is a rational number. 3 can be represented as 3 by 1, or 0 is also a rational number because 0 can be represented as 0 by 1, 2, 3, anything. So all the integers are rational numbers. Okay. So now next let us see the number line. So how do we represent on number line? The middle number is 0. Towards the right, we have all the positive numbers here we can see. And towards the left of 0, we have all the negative numbers. So we can also represent all these numbers on the number line, even the decimal numbers. So for example, I take 3.6. 3.6 is a decimal number. Also, 3.6 is a rational number because 3.6 can be written as 36 by 10 when we remove the decimal. So all the rational numbers can be represented on a number line. Let's take 3.6. So as we clearly know that 3.6 lies between 3 and 4. So this is 3.1, 3.2, 3.3, 3.4, 3.5, 3.6. 3.7, 3.8, 3.9. So this is 3.6. So what is a rational number? All the numbers that we know, natural number, whole numbers, integers, decimals, all these are rational numbers. Now let us see how do we find rational numbers between any two numbers. You have infinitely many rational numbers between any two numbers. So to find, we have two methods. One is the formula method and the other is non-formula method. So the formula is, let me take these two numbers to be A and B. The formula method is A plus B by 2. So from this 1 plus 2 by 2, which is 3 by 2. So I can say that 1, 3 by 2 and 2. So this 3 by 2 is between the two numbers. But this method is little time taking and it's little, consuming. It's little difficult if your numbers are in fraction. So there's another method wherein you need to make the denominators same. So since here I do not have my denominators, I can write it as 1. Now the denominators can be made same by anything. I can make the denominators to be 10, 20, 5, 8, any number. So let me take it as 10. So if I want 10 as my denominator, I need to multiply to both. Same here. So now my question is 10 by 10 and 20 by 10. I've made both my denominators same. Now, how do I find out the rational numbers between them? So once you make the denominators same, you only need to focus on your numerators. So my numerators are 10 and 20. So all the numbers between 10 and 20 falls under this. So I can write 11 by 10, 12 by 10, 13 by 10, 14 by 10, and so on up till 19 by 10. All these rational numbers falls between these two numbers. There's one more important, concept that all your answers might vary from person to person depending upon what denominators the other is taking. So if I take my denominator to be, 30, So then I'll have so many numbers between them and I can take any random numbers. So answers might vary, you need not worry. So this was all about rational number. Now coming to next part, irrational number. So here we have now seen natural numbers, whole numbers, integers, rational numbers. So irrational numbers are quite different, a different category. This is irrational numbers. So irrational number and rational numbers together forms real numbers. So real numbers is another very important concept which you will see in grade 10th. So I'm not going to go in depth. So let's see what are irrational numbers. Irrational numbers are all the root numbers which are not perfect square. For example, root 2, root 3, root 5. Again, root 4 is not irrational because root 4 is a perfect square. Root 4 can be written as 2, right? So 2 is a rational number, so it cannot be irrational. So all the roots which are not perfect square are irrational, including pi, 0.10, 100, 1000, 10000. All these kind which do not follow any pattern. All these are irrational numbers. So on the number line, we have seen that the rational numbers can be plotted. So it is very surprising that you can also plot irrational numbers on the number line. So let's see how. So let me take a very basic irrational number, root 2. So this is a very important concept. You definitely get one question from this. Now root 2 is basically, let me take a Pythagoras theorem. Pythagoras is only for right angle triangle. This is hypotenuse, base and perpendicular. So if I take my base and perpendicular to be 1, my hypotenuse, what will the hypotenuse be? So the Pythagoras theorem states that h square is equal to p square plus b square. 1 square plus 1 square is equal to 2. Right? So what do we get? 1 square plus 1 square. If I want to find h, so it will be root 2. So how do I get this? 1 plus 1 will give me root 2. So let me take a number line. Let us take this as 0. Now, this is 0. So I need to plot this 1 and 1. So from 0 to A, let me take it as 1 unit. 1 unit, you can take anything. It can be 1 centimeter, 2 centimeter, whatever. And from A to this point B, this is also 1 unit. Okay. Now this is forming a right angle triangle. OAB, it's forming a right angle triangle 1 and 1. So this will be root 2 according to Pythagoras theorem. So to plot root 2 on a number line, now you should take a compass, measure the compass of the distance OB. OB should be made on the compass, the same distance. Then put the compass on O and cut an arc on the number line. So it will fall somewhere here. So this point P is your root 2. Point P is your root 2. So basically you need to first calculate this part. Once you get this, then using the same measurements, you can plot it on the number line. Let me show you another example. Let us take root 3 this time. Okay, root 3 is basically root 2 whole square plus 1 square, right? Root 2 whole square plus 1 square. So now again let us take a number line. This is O. Now we need to plot these two. Root 2, we already know how to plot root 2. So the same thing you will plot it here. Let me take the same thing. This is T. This is root 2. Root 2 is done. Now 1 unit. This is 1 unit. From here P to A, I will plot 1 unit. This is 1 unit. So root 2 and 1, when I form a right angle triangle, this will be my root 3. Now taking your compass of the measurement OA, put your compass on O and cut an arc on the number line. So it will fall somewhere here. So this point Q is your root 3. So this is how we plot irrational numbers on the number line. All right. So next up we have decimal expansion. So what are decimal expansions? So let me take 10 by 3. So 10 by 3 is basically 3.333, which can be written as 3.3 bar, which means 3 is repeating multiple times. Or let us take 7 by 8, which is 0.875. 1 by 7, which is 0.142857114. So on, and the same thing repeats. So these are some numbers. Now let us see what are they. So this is known as terminating. Terminating means it terminates, it stops. You will end up having 0 as the remainder. And this is non-terminating. This is again non-terminating because it has bar in it. It will keep repeating. It continues. So rational numbers means either they are terminating or non-terminating repeating. Now, under non-terminating also, we have repeating, recurring, and non-recurring. So under non-terminating, we have two categories, recurring and non-recurring. Recurring is basically repeating and non-repeating. So rational numbers, all the terminating, that means when you end up having the remainder to be 0, or it is not 0, but the same thing is repeating again and again. Now, for example, this one, 3.333, you will never end up having 0 in the remainder, but the same thing is repeating, the same pattern is repeating. So all these kinds are rational numbers. On the other hand, what are irrational numbers? Irrational numbers are non-terminating, non-repeating. Non-terminating, non-repeating. For example, 0.10, 100, 1000, and so on. Here we do not have any pattern, no pattern that the same thing is repeating again and again. So this is non-repeating. But here 3.3 bar is rational number because we know a pattern. Some part is repeating. Though the denominator is remainder is not 0, but some part is repeating. Similarly, this is also a rational number because some part is repeating. All right. Okay. So all these root 2, pi, they do not have any common pattern. Random numbers keeps on repeating. All they are irrational numbers. Now, we can also find irrational numbers between any two numbers. Let me take 1 by 7 and 2 by 7. They both are irrational numbers. So 1 by 7 is 0.142857 and it keeps on repeating. And 2 by 7 is 0.285714 and it keeps on repeating. So if I want to find irrational numbers between them, I can just check my two numbers, 2, 8 and 1, 4. So all the numbers between 14 and 28, let's say 0 0.152857, 0. You know, 216, 0 0.152857, 0.162857, 0.172857. All these are irrational numbers between these two numbers. So this is how you can also find rational as well as irrational numbers. So how do we get 2 by 7? Is just that I multiply this with 2. So 14 into 2, 28. So likewise, you can find out. So this was a basic introduction on number system, first part. So I've explained few concepts. My other video will consist of another remaining concepts. And then maybe we can create one video where we have all the questions in one video. Hope you understood. Thank you.